I take a little bit different route from the other speakers. Second half is a lot of repetition. The first half is a little bit different as far as how we addressed and came up with a solution to our non-potable irrigation water needs. Just a little bit of a background. For Georgia Southern University, we have over 400 million square feet of buildings. Campus is about 700 plus acres. Of that 700 acres, 440 are managed / maintained. We have 10% of our acreage is wetlands, and 45 acres of wetlands and natural areas. This is just a few introductory images to the campus, which you get to see on the tour. This is our landmark, Sweetheart Circle. This is the administration building. It's one of the original 1904, 1900 buildings of the campus. One thing in Georgia Southern, we take pride in our landscape. We've been very fortunate that the administration has recognized that an attractive and beautiful, well-maintained campus plays a critical role, academics aside, in the selection process of where students choose to go to school. And so the administration has been very supportive in the past and the present as far as recognizing that and providing us the direction and the funds to ensure that we have such a campus. And anybody who has ever been to the campus 20 years ago and see it today, I think you'll see that. Just some more images of the campus, our academic corridor. One of our goals in our master plan is to create a pedestrian-friendly campus, and several projects we have initiated. We have our main walkways through the campus. We call pedestrians, which are the main access to the campus, which encourage walking, and we discourage cars on campus. I'll discuss more of that. Again, as our campus, we have our traditional campus features, memorials, landmarks. So, just to get to the main point, we also have our soccer field, our athletic facilities, Paulson Stadium, Jack Clements Baseball Stadium. Okay. And our campus recreation and mural fields. This is a elite facility also. 35 acres of athletic fields in a 7-acre park-like setting. This again was LEED. We did have a part of the LEED process was that we are capturing stormwater and using that for irrigation needs. The problem was that we still had to supplement those ponds with wells, and so we're still using aquifer water to irrigate our fields. So, our dilemma in supporting our green space and trying to protect our investment in our athletic fields and to create that aesthetically pleasing landscape. We were consuming hundreds of thousands of gallons of water getting irrigation during the growing season. Some studies showed us as much as 200,000 gallons of water a day to maintain the athletic fields, to maintain the sports complex, recreational fields, and obviously prioritize those recreation fields. Georgia Southern, we have some of our facilities where some of our buildings where we buy city water. For the most part, our water comes from our own aquifer, our own pumping system, our own well. And we're basically using potable water to meet irrigation demands, and it was putting a great stress on our system. So we really have our water system is not a new system. It's been in place for many years, and trying to produce potable water for the campus and also meet irrigation needs was putting quite a load on the system, and there was some concerns that the system failed. Well, we don't have any water for campus. We're in a dilemma. Also, water restrictions imposed by the state also put our athletic turf investments in jeopardy. Just like everybody else, we have to follow those restrictions. So our solution, and this has been discussed for several years on and off. Never really thought it was going to happen. All of a sudden, the planets aligned for some reason. But working with the local and state authorities, partnering with the City of Statesboro, having meetings with the City of Statesboro and the Georgia EPD, and is EPD here today? Or, no. We devised delivery plan to bring affluent water to Georgia Southern to use for our irrigation needs. And I didn't want to correct the dean when he was here. When he said with gray water, it's reclaimed water is not gray water. Gray water is water that has not been treated or it has to be treated, but it's reuse water. Reclaimed water is water that's already gone through the water treatment plant. That's water that's already gone through the sewer pipes, gone to the treatment center. They have treated that water, and then they are dumping it back into the streams, the watershed. So what we are doing is basically harvesting that, collecting that water, and the city's pumping that water back to the campus for our use in irrigation needs. It's also known as reclaimed water, recycled water, not potable water. So basically, it's we've heard discussion about gray water treatment centers. Well, we're letting the City of Statesboro treat our gray water and then bring it back to us to use for irrigation. Again, the final product is it's filtered, it's disinfected. The city, before they deliver it to us, they chlorinate it, and then when we get the water, we chlorinate it, or we don't chlorinate it, we sterilize it before it's used for the irrigation needs. And again, it's not to be confused with gray water. It's something completely different. Again, the reuse water comes from our City of Statesboro's wastewater treatment plant, which is their plant. This is their treatment plant. Basically, if they treat the water, it gets dumped into a Little Lots Creek, and which then works its way into the waterway system and eventually into the ocean. So what the city is doing is install a pump station, and they're pumping that water back to campus for us to use. One of the reasons why this delivery system was able to work for us was because the city just happened to have some abandoned water pipes in place that they were to use as a method of conveyance to get that water to campus. So there was obviously a lot of infrastructure expenses in implementing this that really helped make this feasible. Also, the city had incentives to provide used water for us also as part of the permit to the EPD. They have to show conservation methods and providing them as far as their permit process. So providing reclaimed water to us is a big plus, a big feather in our hat as far as the permit requirements. Just some of the hurdles and requirements that we had to go through. Again, we were recycling water at the rack, but we were harvesting rainwater, but it was supplemented by well water. At the time we were planning this and implementing it, EPD did not allow us to mix reuse water with storm water. When we have to use a lake for a storage facility for that reuse water that we get from the city, and the EPD didn't want any combination of storm water and reuse water, and mainly they did not want that water to spill over and go back. You couldn't have a spillway. It has to be a closed system. Why? It's never really been quite clear, because the water was already treated and going into the creek at the treatment center, but that's just one of the requirements that EPD has. That basically required us to convert that pond to a sole source pond and divert stormwater around it. Since we have implemented the project, when the city gets the permit from EPD, and then we permit to the city. Since we've implemented the project, the city, EPD has since changed their mind and given the city a permit that does allow stormwater to be mixed with reused water, but you still can't have an overflow. So basically, any of that water that goes to the pond has to be pumped out and used as irrigation. It can't spill over.
But you had already built a new facility.
Yeah, we'd already gone to the expense of rerouting the stormwater, and we were basically using the ditches along Athens Boulevard, the ditches along our road as stormwater. So it wasn't a huge expense, but obviously it was an expensive project, which turned out we did. Some of the requirements, we have to develop an educational program for both the users and the general public. All visible components have to be, as far as sprinkler valves, valve boxes, sprinkler heads have to be identified by the color purple. Some of the concerns we had in the design: can the city meet our water demands? When you switch over to reuse water, you can no longer have a connection to potable water. There could be you can't have a kind of a backup valve in there. There has to be a complete disconnection between the two systems. So you're pretty much committed. Once you to go to reuse water, that's your source of irrigation. And just basically, as in any design of irrigation water systems, just basically the internal operating scheduling concerns of how we're going to operate it, and do we have enough water to meet the demand of our irrigation needs. The benefits is, since it's not potable water, it's not restricted during drought periods. It costs less to produce than potable water. We weren't buying water except for two exceptions. Austin Stadium does buy water from the city, and we will be switching it over to the reused water, so there'll be some savings to the stadium there. Some of our newly developed housing projects are on city water, but for the most part, our water comes from our own well system. So it's not like we have a savings in a water bill, a direct savings, but we do have an indirect savings as far as we've significantly reduce the pressure on our potable water system. And it's just, we can use that water for potable systems and just release that wear and tear off our potable system. And, helps eliminate the expense for drilling future wells and not only the cost, but the permitting process is to do that for potable needs. So we bypass that. Some other potential uses for wastewater, we use it for pest control. Toilet flushing is an option. And also is something that we've considered, but just a concern about as far as the quality of the water. It could be used for children makeup water. Right now, and I'll show you some of the diagrams, the water goes into a pond, and since the water is crystal clear and it has some nutrients in there, we're getting some algae bloom, which you don't want to use, water that has any kind of algae or system for reuse water for the cows. So I think if we can probably take the water directly from the source of the supply from the city, we might be able to use it for makeup water. Again, some more restrictions. Go over these briefly. No more connection to the potable system when you switch over. You can't use it to fill swimming pools or any kind of situation where bodily contact could occur. You can't use it for edible crops. Minimizing the runoff, minimizing body contact. Again, I think these are again, basically reuse water is still something that's relatively new in the state of Georgia compared to other states, Florida and California, where it's been around for a lot longer. So some of this is just states paranoid. Signage, again, some examples of signage you have to put up where the reclaimed water is being used. So this is just a map of how the initial distribution is. This is our Paulson Stadium, football stadium. Here's the main campus. Here are our wetlands. The city brings it to the. It provides us a connection, a meter. And that water is delivered to us low pressure. It's 300 gallon per minute meter, which but it's only under about 30 psi pressure. So we have to, that water is delivered down to, this is our recreation activity center. And these are the two existing ponds that were used for storm water and water harvesting. This pond was going to be the sole pond for reuse water, and this one was going to be maintained from storm water. These two ponds were going to be set, they're connected, they were going to be, they were previously connected, we were going to separate and isolate this one. Since then, and since we can now mix storm water, both of these ponds are now both collecting storm water and reclaimed water, and they are reconnected. They just have to be contained such that these two ponds cannot have an outflow. But from this point, we have a pumping station where this is the reservoir, which holds the water. From this point, we pump it, pressurize it. We have a 1,200 gallon per minute pumping station to distribute the water back under high pressure to our irrigation needs, to the athletic fields at the center. We also pump it back up to Paulson Stadium and the soccer fields. So this is is a map of campus, and the blue is basically our irrigation coverage on campus. Phase 1 distribution, and with this pink overlay shows phase 1 distribution of irrigation needs being met by reuse water. Since this map was put together, we have already implemented a phase 2, which we are now encompassing the central portion of campus with irrigation too. So right now, we'll probably have 50% of our irrigation water needs met by reuse water. Future expansion we're looking at as far as getting it over to the north side of campus. Again, our primary concern is athletic fields, recreation facilities. Those recreational turf, those are the big consumers of water, and those are the big investments we have, and those are important to keep green and growing. And so we'll be looking at distributing that water to the north side of campus. So just some images, and for those who go on the tour, you'll get to see the ponds and the pump station. This is the big pond over at the rack, and then there's a smaller pond to the north of it. This is the pumping station. This was designed, we have to design. Architect. We even talked about putting a green roof on it, but it's not well. Maybe better use of money not to go that far. But this is a pump house. Again, it contains a 1,200-gallon pumping station. This is the ditch that we needed to convert to retention. We're still going to use it as retention and convert it into a boswell. Example of a purple pipe as far as any new piping that is installed in the ground that's going to be reclaimed water has to be purple coated as far as pipe. Any piping that was existing is exempt, so we didn't have to dig up existing irrigation pipe that would have made the project. We would have canned the project if we had to do that, but so obviously we didn't have to make those kind of modifications. So any future installation we do as far as irrigation, it has to be purple pipe. So transitioning from reuse water to what we're doing on campus, and I'll go through these briefly. I'm like, time.
You got 6
some
minutes.
of our sustainable site initiatives that we're doing as far as water quality management. We don't have any cisterns on campus. We've looked at it, and we decided again to focus our funds into the reuse water. But we still take a sustainability approach to our stormwater management, and want to do the right thing. Really taking a focus on a high priority on as far as on-site stormwater management and what that means for Georgia Southern. So just to go through some specific projects. So these are some of the components that we look at. A lot of the projects I'm going to present weren't associated with any building construction per se. It was all retrofit projects we've done later on. Other than the rack, which was a lead project, a lot of these projects we're doing using sustainable initiatives are just things that we want to do because we think it's the right thing to do. Again, part of our master plan of creating a pedestrian-friendly campus, we wanted to get campus cars off of the center of campus, move the cars to the perimeter, and create an environment in the center of campus which was conducive for walking, promote active living, create a walkable campus, create that aesthetically pleasing environment, and in the process also correct some stormwater issues we've been having too. A couple of examples. And you'll see this on the tour. We had Hurdy Drive, but we had a lot of car traffic going right through the center of campus. And so what we did to curb that was we basically cut off some of these streets that are in campus and converted them to pedestrian walkways. Another issue we were having was a lot of these streets, when they were developed, they really had inadequate infrastructure as far as storm drainage. And so a lot of our storm water on campus was running down to the city streets and causing flooding in the city streets, which was quite an issue between us and the city. So in the process of reducing the pervious area and creating more green space, we actually started to correct that problem. We started to decrease our runoff and increase our impervious area. So it was a win-win proposition. Again, in our master planning process, as we at the university presented, we looked at this in our master plan. We looked at the opportunities that we have, not only to protect our existing open space, but where we can create new green space, and in conjunction with the connectivity of creating a pedestrian-friendly walking campus. So we identified parking areas on campus which can be made more green by reducing the size and changing the design in conjunction with pushing the parking to the perimeter. Part of the initiative that has enabled that to happen is we enacted a bus transit system on campus. The students are allowed to park for free at the stadium, and then we have a bus transit system that moves the students through campus. We really couldn't have started reducing the internal parking lots in campus. Instead, we provided alternate means of movement for the students, and so it's been working quite well. And again, it gives us the opportunity to identify some of these parking lots that really don't need to be in the center of campus. Reduce the size and turn them into green space opportunities. Eventually parking lots have become footprints for buildings, but if we can do one step better and make them green spaces before that happens, it's better for the environment. Just another example of streets that we've converted to more sustainable walkways. Georgia Avenue again, which is connects right to the center of campus, our locology and the Hurdy buildings. We had a lot of small parking lots on campuses and streets that basically dead end to the, this is the main academic corridor campus, so we had city streets that could take you right to the main academic corridor, small parking lots which were always full. We had a lot of vehicular pedestrian conflicts, especially during class change. A lot of activity for people trying to get into the center of campus with their vehicles. And again, undersized storm drains were causing street flooding. So the process of converting these streets into pedestrian walkways allowed us opportunities to identify areas where we can create new green space. That's where that parking lot was. We just saw. This is the new walkway. Again, so as far as creating a sustainable site, some of the goals we want to do is, first and foremost, create a safe environment for the pedestrians, create an attractive green space, decrease impervious area, and improve the water quality of the runoff. Capture that first flush that's been mentioned before, and treat that. And just some examples of implementation. We've been using a lot of permeable pavers, especially in secondary walkways. As far as stormwater management, we've identified that we need more walkways. We'll maybe take maybe the first step might be to make them, if they're not major walkways, maybe the first step will be able to just make them mulch paths. but then as you progress, and we see that's going to be a permanent pathway, and we identify we need to pave it, well, we want to use something sustainable, and so we'll use a lot of permeable pavers, which, I don't know if anybody uses permeable pavers on the facilities, but permeable pavers are designed to have that half-inch gap. They're still ADA accessible, but they have the gaps between them, which have clean gravel between them and a clean gravel base below them, which allows the storm water, rainwater to perk into the ground. And again, the goal is to capture that first quarter-inch rain, that first flush, and to let that water perk back in the ground and be purified by plants in the soil before it runs off, and before the runoff carries those oils and impurities into the pipes and into our waterway system. We're using a lot of native grasses as far as water conservation plant material, and also grasses are great for capturing and filtering storm water, and they work well in both wet and dry scenarios. We're very happy. This is Shenandoah switchgrass here. Some of the improved switchgrasses are very pleasing aesthetically and also very functional. Again, that's Georgia Avenue, just to show the transformation. This is what it looked like in 1979. Cars at that one time, the street actually bisected campus. We had a lot of streets bisecting campus. So in the evolution process, we've gone from cars and a lot of runoff and to pedestrian focused. Just some other sustainable initiatives we're doing in support of the prioritizing pedestrians and bicycles and mass transit on campus over the car. Again, some of the street conversions, street closures. We are widening the side where we are having bus routes in conjunction with pedestrian traffic. We pretty much determined that we still need a curb and gutter situation to have a separation between pedestrian and vehicular traffic, even though we have to close the streets to the public. Buses are conversing every 10 minutes or so. We still feel we need a separation in space, but to widen the sidewalks, more street tree planting to create the shade, and incorporated bike lanes. And Forest Drive, using the single-turn, we have considered the option of phase one, we have closed the street and turned it into a transit and bicycle walking lane only, but we're also looking at the option of the possibility of our stormwater management. Forest Drive is a very long street with no catch basins. And since we're not going to be reducing the size of the pervious area, we're looking at the idea of using bio basins along the street to filter that storm water. A bio basin is basically a dry sump, a catch basin, where as the rainwater runs down the street, it goes into a curb inlet, which is planted with it's a sump, a dry sump with a gravel base, but then also has a mixture of soils that can maintain plant material. And the idea